Welcome back. All right, interpreting the motions from the graphs. So I've got two things to cover. One of them I already have, but I want to do a review. That's the position time graph. And the next one is the new one. That's the velocity time graphs that we're going to talk about. All right, review of the position time graph. Remember that the position time graph is the vertical is distance or displacement versus the time. And basically the DT graph, that's what it's called, position time graph, DT graph, is that the slope of that graph, that line, it's always the velocity. And remember, a slope, what was the slope in mathematics? Well, a slope is rise over run. Well, our rise is delta D and our run is T. So delta D divided by T, that's our slope, which is the velocity. All right, that's the slope. Now, we can have curved versus straight lines. In this case, this is a straight line. That means that it's got a constant velocity because the slope is constant throughout this movement. But if it turns out that the graph is curved, that means that the velocity is changing at any given moment. And that's why you're going to see a curve graph. And the shape of that graph is just telling you that based on if it is constant velocity or is changing velocity, then it will give you a different shape. Remember, curvature, that means that it is not constant velocity. Whenever you're dealing with constant velocity, simply you just calculate the slope at any given moment, and then you will find the answer to that. But the other part that I want to talk about is curved graph of xt, or in this case should be dt, by the way, dt graphs, yeah, displacement. By the way, some text, they do have it as xt, as x being the displacement. But here it is. If it's a curved graph, increasing a slope means a speeding up, decreasing a slope means a slowing down. So if I graph something like this, all right, and this is the graph of distance versus time, distance in meters, time in seconds. Well, what's happening is this, that in this case, the slope of this at any given moment on this graph values on this journey where there is different timeline, 1, T2, all the way to, let's say this one, let's call that T5 for different timeline. At any given moment that you want to find what is happening with the graph is that notice that the velocity increasing because the graph is actually sloping up. Now, this is the curvature. When I say the graph is sloping up, what it means is that if I at any given point, let's say that point right there, if I draw a straight line that touches that point, that means touches that curvature. So here it is. This is the line that touching the curve at this point. Let's call this point P. And this line, we call this line a tangent line. In geometry, if we have a line that touches a curve, we call it a tangent line. If a line crosses a curve, we call that a secant line, but you don't have to worry about that. But the tangent line you do know, and in geometry 11, Euclidean geometry, you will learn about tangent lines. That is at the point of P, that's the only point that this line is touching that curve, the curvature of the dt graph. You solve for the slope of this graph. Okay, so you do the rise over run. So this would be delta d, and this would be delta t. This the slope of this graph again will be the velocity, but we call this velocity an instantaneous velocity. And what does that mean? What do you call them instantaneous? Because at that instant of t5, at t5, whatever the time is, we can actually calculate that velocity at that time. And the only way we can do that when it's changing velocity like this, it's going up, it will be calculating the slope of a tangent line, okay, which is very easy. Now, You may not see this until grade 12 probably, but that's what you have to do. And by the way, this one is moving up. The tangent, notice that is increasing. So if I can draw another tangent line on this side like this, the slope of this tangent line at this point right there, by the way, right? Let's call that point Q. Well, the slope of this tangent line, look at that, that's not as steep as the yellow tangent line. Do you see that? So therefore the slope here, this slope is a smaller slope. That means as the time goes by, the slope gets sharper and sharper. That's why it speeds up. That's why the instantaneous velocity is actually increasing. That's what this is saying. Okay, and then if you graph it the other way, like a upside down curve, the other way, it will be exactly opposite. It's slowing down. Let's look at the new thing. This is the velocity time graph. Let's suppose we have this line. The first thing I want to talk about is suppose you have a velocity time graph, and this is the graph that you have. It's basically a straight line, okay? And the vertical is the velocity, that's meters per second. So at this point right here, I'm looking at an object going at 20 meters per second for 4 seconds. So the velocity has not changed. It's a constant velocity. Now, it's constant velocity. By definition, if it's constant velocity, that means what? That means no acceleration. And remember, acceleration was the rate of change in velocity. Okay? So we know that intuitively. So I'm driving at 20 kilometers an hour for 4 seconds. Great. So I'm not increasing speed. I'm not accelerating. But let's look at it in terms of mathematics. Okay? Well, the slope of a horizontal line is 0. So in here, the slope is 0, right? Rise over run. There is no rise here. Rise is 0. It stays 0, right? So we don't have anything. Now, the next thing that I need you to pay attention is this. Let's calculate distance that this object is traveling for 4 seconds at 20 meters per second. Now, velocity was delta D divided by T. Okay? You could actually say it delta T. That's okay too. All right? So we have the velocity. We want to find the distance. So in here, we're going to solve that. So displacement is equal to V times T. I don't have to put the delta T in there, but let's just leave it like that for simplicity's sake. So the velocity, and it's constant, so it's 20 meters per second, traveling at 4 seconds, so you get 80 meters. Okay, so that's just using the formula. We just found out that this object has been traveling for 4 seconds at 20 meters per second, will cover 80 meters. Excellent. Now I want you to pay attention to this graph. Now I want to show you that you can also find this 80 meters using the graph. Now let's calculate the area under this line up to 4. This looks like a rectangle. It is a rectangle, right? So let's calculate the area of this rectangle. What is the length? Well, this is the length. That's 4 seconds. Okay. What is the width? So this part right here. Okay. In this case is 20. How do we calculate the area of a rectangle? Length times width. Okay. So the area is length times width. And in this case, we can say that is 4 seconds. You times it by 20 meters per second. Well, guess what? You get 80 meters. Well, it turns out that the area under the curve of a velocity time graph is the displacement. The area under the curve of the velocity time graph is the displacement. Okay, so that's one more important thing that you need to know. Excellent. All right, now let's move on to an example. Let's suppose I've given you this velocity time graph, and we want to find out the acceleration between different time interval, but for the simplicity's sake, let's do the acceleration in two different time intervals. But we actually know that really the time t interval 10 to 25, the velocity is maintained simply constant. So this area right here, we know that in this area the acceleration is constant. The velocity is constant, so the acceleration is zero. We know that. The slope of the horizontal line is zero. How about the time interval between 0 and 10? Okay, so the time interval between t between 0 seconds to 10 seconds, what is the acceleration? So the acceleration is the slope of the blue line, and again you go up 20. So this is from here, we're going to go up 5, 10, 15, 20. So that's the rise, that is meters per second, divided by, and then across, and that's across, that's 5, and that's 10. So we're going across 10 unit right here, 10 at the bottom, you can see that, right? So that would be 10 seconds, and the acceleration becomes 2 meters per second squared. And it is positive because the placement, the velocity is a vector and it's in a positive direction. The slope is positive as well. We've done the 10 to 20. So t between 10 to 20 seconds, acceleration is 0. It's flat. Velocity has not changed. Okay. But then let's look at between 20 and 25. Well, between 20 and 25, it's very simple. Again, we're going to rewrite it. A is equal to, now this time, rise over run. So we are at 20. So we're going to go down from 20. We're going to drop down to 5, right? So we are coming down in between 20 and 5. Now, because we're coming down, that's negative 15. And remember, another way of writing it, you can do it like this: V final minus V initial divided by the delta t, T final minus T initial, and the top part is your v final is 5 because that's where it is, that's where we are sitting right there, that's your 5 right there. So we should say 5 minus 20, what you start up with, this is meters per second, divided by, and then between the timeline of 25 minus 20 seconds, and then you do the math, you'll end up getting negative 15 meters per second divided by 5 seconds, and that will give us negative 3 meters per second squared. Excellent. So, and then you notice that this slope right here, slope of this line, the slope is negative. Okay, that means direction has changed. That's what it means, right? So negative 3 meters per second. And then the last piece, again, between 25 to 30 seconds, is maintaining the speed at 5 meters per second until the 30th seconds. This is another lesson. Uniform acceleration was the topic as well. So we really talked about the graphic representation of the distance time graph and a velocity time graph. All right, make sure you go back to this note again, pause the video, make sure you go back and review. Don't forget the quiz. With each of the video that I put up, there is a free quiz with the full answer key that has been attached, and it's in a pinned comment as well. Make sure you take that as well and do practice and practice and practice. Okay, until next time.